In less than a century, America has progressed from the sandy hills of Kitty Hawk along the Atlantic coast into the vast new ocean of space. The journey's been difficult and dangerous, but it's also been rewarding. It's given us a better understanding of our home planet, our solar system, and the universe. Although humans have dreamed of sailing outward from the planet Earth for centuries, the realization of that vision began just 5 decades ago.
I had been working for NACA since 1945 as a young aeronautical engineer right out of college in airplane flight test. And we were not interested in space at that time. We were interested in high-speed aerodynamics. The X-15 was being built.
There's the drop. Before it returns to Earth again, the X-15 may fly some 60 miles straight up at nearly 4,000 miles per hour.
We were in Cold War that was darn close to a hot war with the Russians. And there was great concern. Both sides had nuclear weapons.
You know, we grew up fearing the Russians. I can remember when I was in school going through drills where we got under our seats. So this idea of them beating us in space was a pretty awesome idea.
They were claiming superiority. And we didn't believe that, but they had been launching some rockets, and ours too often had been blowing up on the launch pad.
Great balls of fire. Great balls of fire.
And that was sort of the background to what happened then in 57 when they sent up Sputnik.
Here's a Russian satellite which is going over every 90 minutes, beeping. And it didn't take much imagination to know that that could have been a bomb.
I remember being very surprised that they had done this and that we had not been able to do it ahead of them. That was my main concern. I think that was the main concern of most Americans at that time.
Right then, I think we all inwardly resolved that that wasn't going to last. We were going to do something about it.
It was just a faint beep, a radio beacon, coming from a shiny little orb circling the Earth. In 1957, Sputnik signaled the beginning of the space age, and the United States was behind. Our first successful answer to Sputnik came with the launch of the Explorer 1 satellite, and within the year, the formation of the National Aeronautics and Space Administration.
When I came up here in May of 1958, there was no Marshall Space Flight Center. Von Braun and his team were all part of what was called the Army Ballistic Missile Agency. And it was that agency, actually, that built and launched the first Explorer satellites.
Control panel check. Roger. Measuring panel check. Measuring panel okay. 15 seconds. 2, 1. Fire command. Fire command. Contact pressure. Contact pressure.
We took an enormous pride in that because although it followed Sputnik, Explorer 1 had science instruments on it. And so it really marks the first use of space for scientific exploration.
I found my thrill.
It gave us the idea that we were surrounded by radiation belts that we knew nothing about.
On Blueberry Hill, when I found you.
So we were off and running as a result of Sputnik. And it resulted, of course, in the establishment of NASA by President Eisenhower in the summer of 1958.
We have one of the most challenging assignments that has ever been given to modern man. We will be developing and launching into space vehicles needed to obtain scientific data and to explore the solar system. We will be preparing for the day when manned flight goes into space.
Keith Glennon was really outstanding in that period of drawing together the thoughts of the people in the organization and seeking people from outside. Of course, I was a young punk at that time in those early years, and I was a little hesitant about expressing myself, but the way he worked it, it got to a point where it was very common for everyone to really express how they felt.
On July the 1st, 1958, and Dr. Von Braun and about 2,000 of us, that were members of the team, I guess, all transitioned from the Army to Marshall. We were blessed here because the leaders of all of our labs were original members of the Von Braun team. And these guys were brilliant scientists. They'd been there, they'd done it, they made mistakes, they'd blown up more rockets than anybody could ever conceive of, and they were our mentors.
I don't think but about once every 100 years a person like Von Braun comes around. He was a top-notch engineer, he was a top-notch scientist, but he had something that most other people don't have, and he was a visionary. You know, it was crazy about thinking about going to the moon. You know, it was crazy. And Von Braun knew we could do it. And after we'd been around him for a while, we knew we could.
That we have produced more scientific knowledge with our smaller vehicles than the Russians have with their much larger ones.
We were trying to build satellites, trying to get things going, trying to catch up with the Russians and pass them by. And a lot of exciting things were going on in those early days.
An Air Force Thor Able-1 space probe under the management of the National Aeronautics and Space Administration achieved a near-perfect takeoff.
Guys like Max Faget and the Pilotless Aircraft Research Division, who had been designing these rockets over at Wallops, they had all been dreaming about manned in space. And I remember walking into Max Faget's office, and there on the wall he had a picture of a guy in a fetal position in a little capsule. I said, "What are you going to do with that, Max?" He said, "Well, we're going to launch a guy into space." And I said, "Well, you know that the G's are very, very high." He says, "Oh yeah, he'll black out, but he'll come to."
Would you like to swing on a star, carry moonbeams home in a jar?
We knew the Soviets were going to try and fly a man after they launched their first satellite, and the Soviets knew we were going to try to do the same thing.
The nation was getting ready to put a man in space. I mean, that was a commitment and that was the focus. We didn't know much about the space environment. You know, a young person like myself with no experience was on an equal par with everybody because no one had any experience, and it was exciting times, and any information you found was valuable, and people were interested in it and looked at it.
You could be swinging on a star.
But then when they opened this up for manned spaceflight and announced that program and won volunteers for it, I thought that was a natural with the background I had of test flying, and I met the criteria that they were shooting for.
Well, my hand is shaky and my knees are weak. I can't seem to stand on my own 2 feet. Who do you think of when you have such luck? I'm in love. I'm all shook up.
I was a test pilot, and the job of a test pilot is to fly new airplanes. Here, with the dawn of spaceflight, was an opportunity to fly an airplane of a sort that made an order of magnitude jump in height, altitude, and speed and distance.
And they were trying to convince us how neat it would be to get in a capsule on top of a rocket. And I said, no way. Send that idiot that goes out of the cannon in the circus and let him land in a net and forget us. They said, no, don't worry. We're going to put some monkeys and chimpanzees in first. Now I know I want out of here. So I really had a very negative opinion of it.
Before the first flight, we will have developed our Mercury spaceship to the point where it will be as reliable as man can devise. Today we are introducing to you and to the world these 7 men who have been selected to begin training for orbital space flight.
I feel that this is the future of not only this country but the world. We've gone about as far as we can on this globe, and we have to start looking around a bit. And it's just a natural expansion of flight.
Project Mercury is just one part of the endeavor toward space travel.
I got on this project because it'd probably be the nearest to heaven I'd ever get, and I wanted to make the most of it.
These, ladies and gentlemen, are the nation's Mercury astronauts.
Echo was 100 feet in diameter, and it was one of the biggest challenges that we had at Liger.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as Echo.
The real thing that came out of it was that everybody in the world saw it. They knew that the United States was in the space business.
Come fly with me, let's fly away.
Convincing others that humans could do a job in space, that's what we were up to in Project Mercury. 98% of the medical community in the United States did not think man could survive in that environment, much less do a job. And that was very important to the future of manned space flight because it allowed us to take advantage of the human being's thinking capacity, his intelligence, and it simplified the design of the spacecraft, frankly.
And none of us had ever seen a missile launch. And so 5, 4, 3, 2, 1, and the booster launches, and the big flame, and we're standing there watching it go up like this. And here are these 7 budding astronauts watching this. It goes up and hits 27,000 feet and blew. And it just looked like an atomic bomb went off over our head up there. And I remember us looking at each other and saying, we got to talk to some engineers tomorrow morning. That was the initial launch that any of us had ever seen down at the Cape.
That pilotless aircraft division is actually the division that got us into space, because I work for Max Faget, and Max Faget, of course, is the one who did the Mercury capsule, invented that completely.
I'll tell you, it became immediately apparent to me that the only practical approach was the one I had proposed, simply because it provided the lightest way to do it. Our best launch vehicle was the Atlas. The Mercury was the only one that had a chance to be made light enough to be able to make orbit on the Atlas. We didn't call it Mercury that day. We still call it the capsule. The concept we came up with, well, it was it was a primate for Mercury. It was it wasn't quite there.
And then we started launching monkeys and then chimpanzees, and then they launched Yuri Gagarin. We were totally shook by that.
Yuri Gagarin and the Soviets got there first. And that was a terrible disappointment for the nation and for us, of course.
Yuri Gagarin was launched into Earth orbit in 1961. The United States still wasn't there. But the 60s were a decade of change, and NASA would forever change the course of human exploration.
We were getting telegrams like mad from all over the country, from the Association of Prevention of Cruelty to Animals, ASPCA. Please stop launching these chimpanzees. So we launched Alan Shepard.
I always think that Alan Shepard's flight was a fantastic moment in the history of NASA and the history of manned spaceflight. When I think back on that and I watch him come out of that van on the Redstone pad and look up at that rocket in that silver suit he had on, and all those lights flashing and people looking at him and watching and wondering himself what the hell he was doing there, getting up on top of this rocket.
I think the biggest surprise I had in the whole series of events in the space program was after Shepard's flight. Within weeks, President Kennedy said,
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
I thought that is the most audacious thing I have ever heard in my entire life. Are we serious about this?
Remember now when he said that, we had yet to orbit the first man in this country. John Glenn was 10 months away from flying.
The exploration of space will go ahead, whether we join in it or not. And it is one of the great adventures of all time.
Most of us thought he was really stretching the point, and frankly, I thought he was out of his mind.
We didn't really even have computers at the start of this. We were all still using our slide rules.
We set sail on this new sea because there is new knowledge to be gained and new rights to be won.
He was asking us to do what most people at the time thought couldn't be done. But he was doing it in an environment in which the Soviet Union literally owned space. And he laid the gauntlet down. American people picked the gauntlet up and got to a point where they didn't know it couldn't be done.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
That was all heady stuff, and we were all, you know, go man, go.
So to go to orbital speed, you have to go 17,300 miles an hour. That's how fast you have to go to balance gravity. So the first manned flight for orbit was John Glenn.
Godspeed, John Glenn.
Doctors were concerned, for instance, that when you're in zero G for a while, for several hours, they're afraid your eyes might change shape, that you wouldn't be able to even keep your vision on the instrument panel.
Roger, zero G, and I feel fine.
So we were out to prove that those things did not make the difference, but and that's what that first flight was all about.
Oh, that view is tremendous.
I can see
When John flew, he saw these glowing particles at sunset, and they looked a little like fireflies, so he told the ground it was fireflies. And it was a major mystery, but I could create these fireflies by rapping on the side of the spacecraft. It turned out they were little chips of ice, and they fly past the window like a firefly might. My mission ended up being controversial because I overshot the landing by, I think, 200 miles. So my flight did contribute a lot of new knowledge to the science of spaceflight, and it took the form of redesign. But all flights do that. You know, we stand on the shoulders of those who go before us, whether or not they overshoot.
The interesting part of the Mercury mission of Sigma 7 was that we went over the South Atlantic. And prior to that mission, the Russians had set off a nuclear bomb at high altitude. So we had radiation devices that would measure 10 Rankins, 5 Rankins, 1 Rankin, and a half Rankin, something like that. I didn't get a reading on any of those things, so it turned out we were okay. So we could go on and let Cooper go over the South Atlantic over many, many times.
It truly was the age of Aquarius in the 60s. The mood around us was always electric. The press revered the astronauts, and it revered those of us in the front of the program. They looked up to us, and we felt the responsibility, so the feeling was mutual. The country supported what we did.
We were pushing technology.
Stand by to wipe to the bird, and they can lie by the bird. Wipe! And...
Communication satellites, of course, came into being, and a lot of other neat things have happened as a result of that technology push.
The country was trying to build a supersonic transport, at least to do some research and build some prototypes. So by trying to study the flow fields about these vehicles, trying to compute the sonic booms and their propagation to the ground was a very interesting and challenging problem.
There was a lot of interest in Mars, largely because of the publicity which the planet received at the hands of Percival Lowell in the early 1900s. He reported that he saw canals.
The Martians plan to throw a dance for all the human race.
He made out a pretty good case that the planet must have intelligent life form. And so there was a lot of interest in Mariner 4 then, because it was successfully flown past Mars, taking some photographs as it went by. The most important piece of data from Mariner 4 was the photograph number 11, which showed very clearly a crater which looked just like the craters on the moon. Although by today's standards, the quality of these pictures is pretty poor, they were definitely showing that Mars was much more like the moon than it was like the Earth.
Gemini was the program between Mercury, the single-seater in Earth orbit, and Apollo, the three-seater all the way to the moon.
2, 1, 0. Ignition start. Liftoff.
Gemini, of course, carried 2 people, but it wasn't the people that it carried, it was the concepts.
You don't know what we can see. Why don't you tell your dreams to me? Fantasy will set you free.
I feel like $1 million. I'm going to pick up.
Gemini was a great program because we learned how to operate in space, how to do EVA, how to use computers.
I'm picking up good vibrations. She's giving me the excitations.
So what we did with Gemini, we did rendezvous, which I was very thrilled to do. We did the docking, we did the change of orbit, we did a precise re-entry. All of those were very important to going to the moon and back.
Gemini 12, Houston, Capcom, new EVA record, beautiful job.
Apollo 1 was to be the first manned test of the Apollo spacecraft. So it was a real shocker to find that we lost a crew, not in space, but right there on the pad.
The fire on the pad was a traumatic event. It ripped us apart, to be perfectly honest with you. It was a terrible day.
That her face at first just go sleep. Turn the wider shade of pale.
We were not doing a good job. We were running too fast. It forced us to reconsider what we were doing and do the job properly. Without that having happened, I don't think we would have gotten to the moon in the 60s.
5, 4, ignition, your
5 weeks later, as the backup crew, we inherited the first manned Apollo mission, which turned out to be Apollo 7. But As with many things with NASA, what was a disaster with Apollo 1 turned out to be a real triumph with Apollo 7, because the spacecraft itself was a marvelous flying machine. It went 11 days.
We have you go for orbit here, go for orbit.
So we were quite proud of the fact that we took and had a triumph out of a disaster.
And that was what Apollo 7 did for me. It proved that we could do all the things we set out to do and do them well.
This is Apollo Saturn Launch Control. We are still go at this time. T-minus 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. The engines are on. 4, 3, 2, 1, 0. We have commit. We have liftoff. Liftoff at 7:51 a.m. Eastern Standard Time.
Go ahead, Houston. All right, you are go for TLI. Over. Roger, understand. We're go for TLI.
The first full-up Saturn launch of all the rockets went to the moon with humans on it. They never even tested the individual stages. They just stacked them all up, stuck some people up there and says, let's try it out, send them to the moon. That is audacious.
Give us clues to what it looks like from way up there.
I can see the entire Earth now out of the center window.
I see trees of green.
I can see Florida,
Red roses.
Cuba, Central America, the whole northern half of Central America, in fact, all the way down through Argentina.
And I think to myself, what a wonderful world.
This transmission is coming to you approximately halfway between the moon and the Earth. We have about less than 40 hours left to go to the moon.
The first time we flew a crew on a big Saturn V, we sent them to the moon. For 10 orbits, not just to swing around the back. Very bold decision.
The moon is essentially gray, no color. Looks like plaster of Paris, or sort of a grayish beach sand.
On Apollo 8, when we rotated the spacecraft and saw for the very first time the far side of the moon, only 60 miles below, we were like three school kids looking into a candy store window. Kind of forgot the flight plan for a second as those ancient old craters on the far side slowly slipped by.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good Earth.
I think to myself, what a wonderful world.
Frankly, I wasn't too optimistic that Apollo 11 would actually land and actually return somebody successfully. I thought we'd get away with our lives. I wasn't too worried about that, but I just thought there were so many unknowns that I would have given us about a 50-50 chance of being the first flight to land and return someone safely.
All flight controllers, go, no go for landing. Retro. Go. Fido. Go. Guidance. Go. Control. Go. Telcom. Go. GNC. Go. Ecom. Go. Surgeon. Go. Capcom, we're go for landing. Altitude 4200. Houston, you're go for landing, over. Roger, understand. Go for landing. 3,000 feet.
There are certain events in life that you never forget. And the lunar landing, and in particular the last seconds leading up to the landing, will never be forgotten. We had battled to get to the surface. We're halfway to our abort limit. About the time we got that sorted out, we started having a series of computer program alarms.
1201. 1201. Roger, 1201 alarm. 1201 alarm. Stand type, we're go flight. Okay, we're go.
And as the crew took over at about 2 minutes prior to landing, searching for a landing site, we knew that they were going to be using a lot more fuel than we had expected.
540 feet and a 15.
They keep doing this, they're going to run out of fuel.
Altitude, velocity, light. 3.5 down.
Didn't really have a good hard feeling about just how far they were from actually landing, you know. They kept going and going and going, you know. And
what were our chances of landing successfully? Getting outside, that was pretty easy to do. It was touching down so that later missions could touch down and then do the rest of the stuff. But the landing with 15 seconds of fuel remaining, that was the important thing.
4 forward, drift into the right a little. 30 seconds forward, drift. Contact light. Okay, engine stop. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed.
it was like, gee whiz.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Okay, keep the chatter down in this room.
The unfortunate thing is no controller had an opportunity to absorb the emotion of that landing because we had to work for the next 2 hours, nonstop.
Okay, T1, stay, no stay. Retro. Stay. Fido. Stay. Guidance. Stay. Control. Stay. Telcom. Stay. GNC. Stay. Ecom. Stay. Surgeon. Stay. Capcom, we're stay for T1. And we're getting a picture on the TV. You got a good picture, huh?
Up until that moment, television had always been a goal, but not a requirement.
The limb footbeds are only depressed in the surface about 1 or 2 inches.
Once we landed safely, the only thing that counted was for us to see the picture.
I'm going to step off the limb now.
What I felt at that moment was the TV better work or else, and if it doesn't, they really will know who I am because I'll be the man who didn't bring you television from the moon.
That's one small step for man, one giant leap for mankind.
Come on, come on, come on, come on, now touch me, babe. Can't you see that I am not afraid? What was that promise that you made?
Oh, that looks beautiful from here, Neil. It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here. Beautiful view. Isn't that something? Magnificent sight out here. Magnificent desolation.
The world just marveled at this right along with us, and we more or less made the whole world our partners in this thing by inviting people to be there. I think that's one of the best things we ever did in the space program, and one of the best decisions ever made with regard to the space program was to share that with the world.
For one priceless moment in the whole history of man, all the people on this earth are truly one.
Come on, come on, come on, now touch me, babe.
I think it was the biggest event from an aviation point of view and probably from a scientific point of view that happened in the 20th century and maybe in the history of man.
Here men from the planet Earth first set foot upon the moon, July 1969 AD. It came in peace for all mankind.
11, Apollo 11. This is Hornet, over. Apollo 1, there's Apollo 11, reading you loud and clear.
Well, we had a good time on Apollo 12, and so we were happy to go and anxious for the great adventure. And so off we go, and we go into a thunderstorm immediately after launch and get hit by lightning, and it lights up a lot of caution and warning lights, and we didn't know what to do.
I don't know what happened here. We had everything in the world drop out. I'm not sure you get hit by lightning.
Thank God for Mission Control, because they came up and gave us some advice, and so we powered it back up again with their help, and everything worked out okay. We went into orbit and then off to the moon.
Hey, there it is. There it is. Son of a gun, right down the middle of the road.
They landed us perfectly. If we had not touched the controls, we would have landed right in the middle of the crater that we were shooting for.
Boys on the ground do okay.
So they wouldn't have missed it by 10 feet. And when you figure we went 240,000 miles, that's pretty amazing. Shows you the kind of capability that NASA has.
He's got it made. Come on in there. 24 feet. Contact light. Roger, copy contact. And that may have been a small one for Neil, but that's a long one for me.
So we got out for that time, and we placed some experiments, and then we collected a lot of rocks and made some observations.
I have the decided impression I don't want to move too rapidly, but I can walk quite well.
And then our primary job had been to land near Surveyor, which was an unmanned spacecraft that had landed on the moon in the Ocean of Storms some 33 months earlier.
Boy, you'll never believe it. Look what I see sitting on the side of the crater. The old Surveyor, huh? The old Surveyor, yes, sir. Does that look neat?
So we were going to land there and pick up some parts like the TV camera and the scoop and things like that, bring them back to Earth for evaluation.
Apollo 13 was a team effort from the very beginning to the end.
Okay, Houston, we've had a problem here.
Go ahead. We've had a hardware restart. I don't know what it was.
Okay. Houston, we've had a problem.
When the crew threw the switches to start the crowd stir, a spark jumped between the fan and the heater assembly, and the pressure in that tank rose very rapidly because the insulation had been damaged on the system. And we now had a fire inside the tank that blew the dome of the tank off.
That'll make me bus wonderful.
That series of events started the saga of Apollo 13.
And we had a pretty large bang associated with the caution and warning there.
The exact words I used in mission control is, "We have never lost an American in space, and we sure as hell aren't going to lose one now. This crew is coming home. You got to believe it. Your team must believe it, and we must make it happen."
It looks to me, looking out the hatch, that we are inventing something.
When we suddenly realized the true significance of the explosion, seeing the oxygen escape from the rear of my spacecraft and consequently losing all the electrical power and the propulsion system, we knew we were in serious trouble.
Have you called in your backup ECOMs now? See if we can get some more brain power in this thing? We got one here. Roger.
Throughout the entire Apollo 13 mission, the teams in mission control changed shifts almost regularly at 8-hour intervals. And the teams kept the mission going, kept working the problem as my teams tried to come up with the answers.
Go ahead, Flight. I want you to get some guys figuring out minimum power in the LEM to sustain life.
Fortunately, the lunar module was attached to us, and when that occurred, with oxygen almost gone in the command module, we transferred the command to the lunar module, and try to use it somehow, some way, as a lifeboat to get home.
Let's solve the problem, but let's not make it any worse by guessing.
I got a lot of recognition for the work that we did, but the real heroes of Apollo 13 were the people in the back rooms and over in the engineering facilities who came up with the answers we needed.
We never talked among ourselves about not making it back home. It was like playing a game of solitaire. As long as we had a card and we could put it someplace, the game kept going. And every crisis that we came up to, we found a solution. As we rounded the moon, and my two companions looked at the place where we were supposed to land, and they were very much disappointed. I said, we're on our way home. Let's get home successfully and forget about the landing.
And there's one whole side of that spacecraft missing.
Is that right?
The whole panel is blown out, almost from the base to the engine.
It's really a mess. Man, that's unbelievable. Let's get it. Okay, copy that. Farewell, Aquarius, and we thank you.
Apollo 13 has to rate with anything we ever do because it took a great deal of ingenuity, a great deal of preparation, years of preparation, a lot of guts on the part of the astronauts themselves to bring that off.
Odyssey Houston standing by, over.
Apollo 13, this is recovery, over. The recovery, Apollo 13 is descending. Under Apollo 13, this is recovery, and your chutes look good.
And so you have to say that Apollo 13 was a fantastic moment in the history of manned spaceflight.
I will tell you that we had one of the most bodacious splashdown parties that I can remember when those guys got back.
Looking straight. 20 feet. 10. 3 feet per second. Contact now. 2, stop. Auto. We're on the surface. Okay, we made a good landing.
Roger, and two.
You might recognize what I have in my hand as the handle for the contingency sample return. I just so happens to have a genuine 6-iron on the bottom of it. I'm going to try a little sand trap shot here.
And if the passenger in starts playing different tunes,
Miles and miles and miles.
on the dark side of the moon.
Come on out here and give me a salute. Big Navy salute.
Charlie, set form.
Oh, Seaman. How about that? I'm going out for the ballet when I get back. You learn another line of work up here. John, you're just beautiful. That is the most beautiful sight.
What's that?
You're standing there on the rim of that crater.
Doggone, I've never heard John described as beautiful.
No? Well, he's not real. Well, actually he is on this thing, I'll tell you. He's a big rooster tail out of all 4 wheels, and as he turns, he skids, the back end breaks loose just like on snow.
Hot Rod Lincoln.
Now, I tell you, I can't see to the bottom of it, and I'm as close to the edge as I'm going to get.
All the different steps and all the different pieces of hardware, and all of it had to work. And it's just inconceivable that we could do something like that. The motivation was, well, it ain't gonna be my part that screws up, I want to get it right. And apparently everybody else felt the same way, and we did it, and did it, and did it, and did it.
Look out, baby, now here I come. I'm bringing you love that's true. Get ready.
Apollo 17 was probably one of the more interesting
missions because we had a real geologist there, and they landed in a wonderfully interesting place.
The Valley of Torres Littrow was picked as a landing site for a couple different reasons. Number one, it was in an area of the moon we had never even come close to, and it was a valley some 20 miles long and 5 miles across, which was literally surrounded by mountains higher than the Grand Canyon is deep.
Yeah, 1.2 kilometers is a long way from the limb. Look at the Challenger down there. Make you get a feel for how big this valley really is. I'd rather not. Holy smoly! Why are we on a slope? No, dadgummit.
Hey, Gene, would you go over and help twinkle toes, please, Gene?
Really?
We stopped, obviously, at a lot of different planned places, and we did everything from drilling core samples to setting up experiments to drilling trenches and so forth.
There is orange soil. Well, don't move it till I see it.
And I thought, okay, this scientist has been on the moon too long. He's been breathing too much oxygen. There's not going to be any orange soil.
Hey, it is! I can see it from here. It's orange.
We not only did a lot of work on the moon, but we had a good time. And you know you're only going to come that way once in your life.
I was strolling on the moon one day in the merry, merry month of December. No, May.
I just looked around, and knowing we were leaving, know we weren't coming back, and I said we now leave as we once came, and God willing, as we shall return.
This valley of history has seen mankind complete its first evolutionary steps into the universe, leaving the planet Earth and going forward into the universe. No more significant contribution has Apollo made to history.
American pie. Drove my Chevy to the levee, but the levee was
Right away, Houston.
Them good old boys were drinking whiskey and rye, singing this'll be the day that I die.
When you look back on that now and see how long it's been since we've flown to the moon, you realize not only how difficult it was, but how unique it was, how marvelous it was. Frankly, it's hard for me to believe sometimes that we did it.
The political achievement, not to mention engineering achievement, of putting humans on the moon and bringing them safely back to Earth, and then proving it wasn't a fluke by doing it 6 times in all. That was fantastic.
We take for granted today that technology has come from Apollo. We live in a different world today because of Apollo.
Although Gene Cernan was the 12th and last American to set foot on the moon in 1972, the exploration of space did not end there. It simply turned the page. In the decade of the 70s, NASA's unmanned explorers set out on journeys that would cross millions of miles and show us worlds that, until now, had only existed as tiny points of light in the night sky.
You know, I got right in the beginning of Landsat. NASA really did something unique in that program, but people don't really recognize. We started the whole digital camera color analysis, but it turned out to have this incredible characteristic that it can cover large areas at the same time, bring out small deviations in the characteristics of the Earth, and you can use color to interpret it, to therefore calculate what was in the various areas.
She packed my bags last night, pre-flight. 0 hour, 9 a.m. And I'm gonna be high as a kite by then.
I was in the desert in Kenya on an eclipse expedition.
And we saw the fragments around Skylab go over us, and I thought, oh brother, there's been an accident in the Skylab launch. My hopes and desires for the science that was going to come out of Skylab, I thought, well, it's cooked.
On such a timeless flight.
In 1973, I was commander of the second Skylab mission, and Jack Lousma was the best EVA guy that I've ever met. And I said, if we send Jack out there and let him work on that thing, he'll find a way. Lo and behold, he goes out there and fools around with it a while trying to get these connectors undone, and finally gets them undone and puts it all together, and it worked great.
And it went on to a brilliant scientific discovery, which had to do with coronal mass ejections. And for the first time, we were able to see these, where big chunks of the corona blow off.
It's day after day of hard work. And even though you have a nice view out the window, that doesn't kind of pay you back for the constant effort that you have to put out to be productive in space. It's a tough job, and only dedicated humans can do this sort of thing.
It operated for about 9 months, which was much longer than had been anticipated. And at that time, we understood some things that we'd never understood before, and it gave us some forward momentum in the science that it continues right now till today.
Glad to see you.
Let me call to express my very great admiration for your hard work, your total dedication in preparing for this first joint flight.
Today is not far off when space missions made possible
by this first joint effort will be more or less commonplace.
One of the huge surprises of the mid-20th century came with one of the Mariner spacecraft. And the Mariner spacecraft started towards Venus, and they found that the sun's magnetic field, far away from the Earth, was about as strong as the Earth's magnetic field. Now, I had been taught, and everybody else had been, that the sun's magnetic field would be negligible. And so it presented us with a tremendous confrontation of how could that be so?
Venus and Mars are all right tonight. Is there life on Mars?
The one planet that was most intriguing to humans, human scientists, was Mars. Mercury was closer, but it was very inhospitable. Venus was the nearest one to us, but it was very inhospitable because the atmosphere was toxic and hot.
Mars showed seasonal variations that suggested something was alive. And I think that was the basis for creating Viking, to see if there was life on Mars. When we got down and found out how dry and arid and barren the place really was, came as a bit of a surprise.
I've been through the desert on a horse with no name. It felt good to be out of the rain.
We had hoped to find microscopic life. The thing that happened that kind of left us in a quandary was the 3 experiments that were directly life detecting. Did it breathe? Did it eat? Did it do photosynthesis? All said there's something here. And when you tried to find the dead bodies, you couldn't. So that kind of left us in the position why the jury is still out.
In the end, we ended up with 2 successful landers on the surface and 2 very successful orbiters that exceeded their lifetime by many, many months. So obviously, we were all elated, and all you could say, we did it, we did it.
When we flew by Neptune, people were standing in line at night at planetariums
in order to be able to see the images coming in from Voyager, because they weren't on the web in those days. There was no web. You had to go somewhere in the middle of the night to see it. It became a worldwide event when Voyager was flying by these worlds, and I had no idea that it would have that kind of an impact. And of course, that in the long run is the most important thing Voyager's done, is show how much there is, the new frontiers of space.
You're a shining star, no matter who you are, shine bright to see.
The 1970s really saw the start and heavy activity in the project aircraft area, which initially focused on STOL aircraft and then moved into the VSTOL arena. So the rotorcraft work got underway very heavily and has continued to today until it is the remaining flight research activity.
There were about 5 of us that came into the Space Systems Division that had been formed to support shuttle development.
Working on mysteries without any clues.
Coming to work was fun to do that kind of thing.
Working on our night moves.
That was a little bit unique. It was kind of like having some very expensive toys to play with.
The development of the shuttle, I think that was a magnificent development program. You know, there were an awful lot of people, including some people at Langley, that were very hesitant that the shuttle would be successful. Would all those thousands of thermal tiles underneath protect it? Would it burn up? It turned out to be a tremendous opportunity.
6, 5, 4. We've gone for main engine start. We have. America's first space shuttle, and the shuttle has cleared the tower.
A vehicle that could launch into space as a rocket, put 25 tons of cargo into orbit, and land on a runway like an airplane. Not just once, but over and over again. In the 1980s, NASA would rip this concept from the pages of science fiction and place it squarely on the cutting edge of space travel.
Going up the launch pad, looking up and seeing, this huge, rocket that kind of sounds like an animal. You can kind of hear the gurgling and the hissing, and it sounds like it's alive.
The few seconds right before liftoff, every time I've done this, has been a little bit of fright about whether I really want to be doing this or not.
10 seconds, we have go from main engine start.
I was really just focusing right on the tasks at hand and trying not to think about the fact that tons and tons and tons of rocket fuel were about to explode around us.
Liftoff of Shuttle Discovery.
Discovery, roll program. Roger, roll, Discovery.
Discovery on the proper alignment of the 8.5-minute ride to orbit. Six seconds into the flight.
The forces and the sensations are just powerful beyond imagination. They shake you so much that you can hardly see the displays in front of you. Right after the solid rocket boosters are jettisoned at 2 minutes, it's a very smooth ride. The acceleration is very powerful, and you're on your way to orbit with a very different feeling.
As soon as you achieved orbit, the engines cut off. Just instantaneously, you go from being pressed in the seat to hanging in your straps and sort of floating in the cockpit.
The fact that I was going to be the first American woman to go into space carried huge expectations along with it. And of course, it was very important to me that I understood my role really well and that I was really well prepared for the mission, because the last thing that I wanted to do was get into space and make a mistake. So I wanted to be very, very sure that I was able to meet the expectations.
Every step you take, I'll be watching you. Oh yeah, human combat. Maybe your mind's too fast.
But it wasn't for me a desire to be the first African American in space. My desire was to make a contribution, just to make a contribution. And I think I probably told people that I would probably prefer not being in that role versus being in that role, because I figured being the number 2 guy would be a lot more fun.
Well, as you can see, we're having a lot of fun up here trying to figure out what happens to the human body in zero G.
We are the world. We are the children.
It feels like you weigh twice as much as you normally do during the entry portion. Once you get on final, all of the emotions and focus are just on that last little bit of landing, and it's a neat way to end a flight when you actually get to put your hands on the stick and fly it yourself.
Gear down and locked. Touchdown.
Engines throttling up, 3 engines now at 104%.
Challenger, go with throttle up. Challenger, go with throttle up.
We come together today to mourn the loss of 7 brave Americans, to share the grief that we all feel, and perhaps in that sharing to find the strength to bear our sorrow and the courage to look for the seeds of hope.
Risk is something that we have to just really consider as part of our life, especially in exploration. I know we've had some tragedies, and we'll probably have tragedies in the future, but you know, the ones that we've lost were probably the first ones to tell you, keep pressing on, don't stop because of us.
My role as a mechanical engineer was to find out, you know, what fell apart or what happened. And we finally found that the O-ring is supposed to be designed so that pressure on one side pushes them more securely into place. The housing for that big O-ring was just the opposite. The pressure actually pushed it out. Finally, of course, when the thing burned through and actually burned the nozzle through, it was pretty obvious to see what the problem. So with we got the job of redesigning.
1, 0, and liftoff. Liftoff. Americans return to space as Discovery clears the tower.
Roger roll, Discovery.
Yeah, I'm free.
Good morning, Discovery. And you got to go for HST deploy ops.
NASA opened the decade of the 90s by placing the Hubble Space Telescope into orbit. It would peer farther into space and further back in time than any other telescope. And in the closing decade of the 20th century, Hubble and a host of other robotic explorers would provide astonishing new views and perspectives.
Everybody was up. We were off to discover the secrets of the universe. It was great. And then things started to be sort of scratch your head. Why is it taking so long? Why can't we focus the telescope? What's going on? What was wrong with Hubble is kind of the same thing that's wrong with your eyes when you need glasses. Basically, the shape of the lens was wrong. So in essence, the telescope was nearsighted and it needed some glasses. I was taking a shower in the hotel in Germany, and they have these really funny shower heads where the shower head will kind of move up and down and back and forth, and that's when it dawned on me. We can have this instrument robotically raise up the corrective lens, flip out, if you will, just like that shower head, these other corrective optics, to correct the aberration for all the instruments. All of the work leading up to the first servicing mission is probably the most exciting time of my career.
The NASA program changed the nature of astronomy. We made some extravagant promises on Hubble. We undersold the program. Whatever we said, Hubble did better, I think. It really changed the nature of what we know.
Hubble is one of the most phenomenal things we've ever done in space. Data that we get from Hubble will continue to change the way we think about ourselves, about the universe, and our place in it. You know, the pictures from Hubble are iconic. You see them everywhere. The fingers of God. This is the gas pillars that are actually many, many, many light years across. So the scale of these things is enormous. And you're actually seeing the birth of stars. It's a star nursery. It starts to give you a sense of how small we are and how vast the universe is. And that's my favorite picture.
NASA, especially Goddard, was the place where I could carry out the dreams that I had, which were to push forward an experiment that would measure the Big Bang radiation better than anyone had ever tried before, and took on the job of working on COBE. For many decades, people didn't agree with the Big Bang theory. They thought something else must be true. Generations of astronomers thought it must have been the steady state theory. Einstein didn't like the idea. So when we got the measurements that fit exactly on the theoretical prediction for the Big Bang, this tremendous sigh of relief went through the world as well. Our measurement of the hot and cold spots in the Big Bang radiation, which show us not only is the Big Bang theory right, but also it gives us the map of the seeds of the structure, the things that will eventually grow into galaxies.
The Galileo probe, which sent its spacecraft into the atmosphere of Jupiter, was the most demanding entry probe ever flown by anyone, and it worked perfectly.
Europa and some of the other satellites where there seems to be accumulating evidence for water are getting to be very, very interesting places for exploring. I mean, who knows what's under the ice surface on Europa? You've got water. Looks like there's salt water. You wouldn't have water if you didn't have a source of energy. The odd coloration gives some hint of the presence of organics. When those conditions held on the early Earth, life developed in a couple of 100 million years. Well, maybe there's something interesting on Europa.
I'll tell you, there is nothing as beautiful as Chandra sailing off on its way to work.
Nowadays, we're discovering what is the universe really like, and it's totally magnificent. And one can only be inspired and awestruck by what we find. So I think a proper response is complete amazement and awe at the universe that we're in. And how it works is just far more complicated than humans will ever properly understand.
Houston, Atlantis, we have capture.
Mir was a successor to the early Salyut space stations that the Russians built back in the 70s.
Well, I was extremely fortunate that I was able to be part of the Shuttle Mir program. So obviously, there were a lot of challenges when you're trying to work with a different culture. I mean, it was a challenge for the Russians, it was a challenge for the Americans, but everybody wanted to work together to make it come to pass.
I definitely think it started teaching us the lessons we needed to learn, and it was key to that. Very technical things that, you know, seem simple but become very complicated just by language and cultural definitions of things that, you know, I think our guys did a phenomenal job bringing all those pieces together.
Booster ignition and liftoff of Discovery with a crew of 6 astronaut heroes and 1 American legend.
The flight I was on, Discovery in '98, we had 83 different research
projects on that one flight. You go up for a couple of weeks, say, and you find some of the things occurring on the human body that are much the same as getting old right here on Earth. The body's immune system changes. You get less resistant to disease and infection. The body's ability to replace protein in the muscle becomes less. And so the question was, could we find, by comparing my reaction to the younger people's reaction to this up there, could we maybe get a clue as to what within the body turns the human system on and off with regard to immunity? Hopefully we can find ways maybe to make it possible for younger astronauts to go on longer missions without having some of the problems they have, and at the same time cut out some of the frailties of old age for people here on Earth.
Houston Endeavour, we've got Unity firmly attached to Endeavour, and we're off to a great start on building the International Space Station. Houston Endeavour, we have capture of Zarya. Physical separation, executing SEP burn.
We have ignition and liftoff. Liftoff of the Soyuz rocket. We have initial contact of the Soyuz capsule with the Expedition 1 crew to the International Space Station.
The hatch was opened at 102140 Universal Time. The first expedition on Space Station requests permission to take the radio call sign Alpha.
We are on a true spaceship now, making our way above any earthly boundary, that our crews can work together as equals and our countries as partners.
All the other vehicles we had ever built could be totally assembled, put together, and tested on the ground before you launched them into space. The space station is so large, you know, it's 360 feet wide, 280 feet long, 120 feet thick or something like that. It weighs 1 million pounds, and it takes 46 or 47 assembly flights just to take up all the pieces. So every time you brought up a new piece, you had a different spacecraft that had a different set of requirements, and basically a new spacecraft. And at each stage, it has to operate completely successfully for an extended period of time.
Even as the International Space Station was being assembled in orbit, Spirit and Opportunity would soon rove the Martian landscape. But early in this new millennium, we would endure a tragic reminder of the dangers of space travel.
And Columbia, Houston, we see your tire pressure messages, and we did not copy your last.
Roger.
At 9 o'clock this morning, Mission Control in Houston lost contact with our space shuttle Columbia. A short time later, debris was seen falling from the skies above Texas. The Columbia is lost. There are no survivors.
NASA has been charged with advancing the technology and understanding of spaceflight for this country, which means we're on the cutting edge of what can be done. Then we're going to be taking risk.
And spaceflight is one of the areas where we face risk on a daily basis. And in the process of doing this, we develop the new technologies, new techniques, the new inventions. We make discovery. This is what's going to keep us powerful and safe and secure and assure the economic vitality of our nation.
One, two, three.
We actually put our many years of hypersonic research here at Langley into work, into a vehicle that actually flew with the HyperX program, which was indeed an exciting program. This was put on a Pegasus booster, taken up to test point, and then released.
3, 2, 1, launch.
Sequencer reset.
At that point, the X-43 would ignite. We had two vehicles
Mach 7, and then we had a Mach 10 vehicle. We broke our own record. The Mach 7 was the first record breaker, and then we broke our own record with the Mach 10 as far as speed.
I had a great time working on airplanes and fighters and stuff. The agency not only built and flew some very cool things, we also had a lot of research that then got onto other airplanes. We did a lot of work that ultimately led to things that are on the F-22 and F-117 and maybe on the Joint Strike Fighter. We don't build 747s and we don't build F-22s, but we certainly did things that help the companies that do build those kind of flight vehicles make their airplanes better.
It was a good maneuver.
3, 2, main engine start, 0, and liftoff of the Delta rocket with Opportunity, a chance to explore and unlock the secrets of our neighboring planet.
The reason we send unmanned spacecraft is to pave the way for humans. The reason we've got Spirit and Opportunity on Mars is to tell us a little bit about what it's going to be like, the things we're going to encounter when we get there. Because it's man's intellect, it's man's intelligence that you can never recreate this computer.
We intentionally made them so human. We gave them 20/20 vision. We gave them the ability to move around in an environment. We gave them an arm so that they could reach out and touch things. And then we used them to do exactly what we would do if we were there.
One thing that NASA gives us is a very different perspective on the whole universe, including our own world's place in it. When we look at other worlds and we look through the eyes of a robot at a frozen desert, we appreciate our own world so much more because we see what it could be like.
When they die, it will be sad, but they will have led such long and productive lives and will have died honorable deaths that I'll be at peace with it because of what they've done. These are machines, after all. But you feel an emotional attachment. We've put so much of ourselves into these things that when we lose them, we'll lose a part of ourselves. It'll be hard. I'll really miss them.
T-minus 10 seconds, go for main engine start. 7, 6, 5, 3 engines up and burning. 3, 2, 1, and liftoff of Space Shuttle Discovery, beginning America's new journey to the moon, Mars, and beyond.
When you approached the space station, it actually felt like it was enveloping you as you got close to it because the size of it was so immense. You could hardly take it in, and all the windows are your peripheral vision. And it seemed like you were flying into a canyon, like in Star Wars almost, and it totally surrounded you. But it's a wonderful feeling to see the space station coming up, and it's being framed by the Earth below. Very beautiful views, trying to distract you from your task of flying the space shuttle.
When you arrive on the International Space Station, there's a little bit of a shock factor. It was very odd when they closed the hatch and we weren't on that shuttle. We saw them flying away and it was like, wow, we're really here. Man, this is going to be a long visit.
We get scheduled for approximately 2 hours of exercise a day, and that's to try and counteract some of the negative effects of being in zero gravity on the musculoskeletal system and our cardiovascular system. So that was an important aspect of every day that we're on board the station.
The crew members themselves are laboratory rats, if you will, because we have a human research program trying to understand what happens to people when they're in space for long periods of time, and so we participate in those experiments.
Obviously, I also think the space station offers an incredible laboratory. We've added additional laboratory modules during Expedition 16 and with the most recent addition on the last shuttle flight. So it's going to be, I think, a spectacular laboratory as well, and I'm excited about what the future holds for us there.
This is the command post. We have both an American laptop and a Russian laptop there.
Probably the biggest legacy of the International Space Station, I think, will be the international aspect. The fact that we're doing this internationally, it's a huge technical accomplishment, but I think the fact that we are overcoming these cultural obstacles and bringing these people together with this common goal, I think is one of the most significant aspects of the International Space Station.
I believe that human beings should expand into space. By doing that, we can learn about ourselves and make the society and the world better. By working together in a cooperative way, we can bring the world closer together. This is a great opportunity for Japan and other countries to be able to participate in a space program like the ISS.
NASA labs are the pride of the world for things that we can do, where science and engineers meet together and say, let's do the impossible, and we'll do it. Our space projects are very demanding. A person has to work maybe night and day and weekends, so when the schedule requires it, to finish something on time. I feel that the entire world is watching us and waiting for us to do our thing and to get it right. And it's a tremendous opportunity. It's also a tremendous responsibility. And it's always been pretty clear that we do this together as teams, and that it's the only way you could possibly do these amazing projects. So I think we can be very proud of what we've accomplished. We look back in history and when we think this country was founded in part by a scientist, Ben Franklin, and a future president, Thomas Jefferson, who was very fond of science. And so they would be so proud and thrilled to see what our country has accomplished with science and the engineering miracles that have happened in consequence. I think they never would have guessed, but they would still be thrilled to see what's been done.
As NASA enters its 6th decade, it's time to go back to the moon. This time we'll go back not just for a few hours, not for a few days, but for good. For the good of exploration, innovation, and inspiration. For the good of humanity.
We will give NASA a new focus and vision for future exploration, to gain a new foothold on the moon, and to prepare for new journeys to the worlds beyond our own.
We, as a civilization, must explore. That's who we are. Intrinsically, that's who the human race is. We're explorers. And unless we continue to explore, we're going to falter as a civilization.
When we cease to be an exploring nation, when we cease to seek knowledge and ask questions, that's the time we will wither and die on this planet. I think it's significantly important that we look to the future.
Mars, of course, will be the next outpost. I think we'll have people living on Mars 50 years from now. What they'll be looking forward to, I have no idea, but I'm sure it'll be fascinating.
I'd like to see the mission to Mars be accomplished. It's something I did some work on in making the proposal we made. I think there's a consensus that going to Mars is a worthy objective, and I'd like to see that accomplished.
Perhaps at one time in the distant past, at least some basic life forms existed on Mars, and perhaps could again in the future. These things mean a lot to me. I think space is important, and I think America should continue to be in the forefront of space exploration.
No matter where you go in the world, people know what the letters NASA stand for. They say NASA, and they say it with recognition. That in of itself tells you that NASA stands for something in the world, not just in America, but across the world.
throughout all human history. We've always had people look up and think, you know, the blue sky, what is it up there? Gee, I wonder what it'd be like if we could go up there. In our time, our lifetimes, we've gone up there. You know, here we are, developed that kind of a capability in our time. What a great time to be alive.
The future of mankind depends upon space travel. If we stay on Earth, we'll go on having wars. But if we go to the moon and Mars, we'll bind ourselves together into one single race, one color, and go into space and live forever.
Remember,